What if aliens already visited Earth and the evidence has been published for decades? Here are 10 discoveries that no one has been able to fully explain. Alright, let's go. Number 10. The WOW signal. In 1977, astronomer Jerry R. Emmon was reviewing data recorded by Ohio State University's Big Ear radio telescope as part of an ongoing SETI survey when he noticed something in the printout that stopped him. He circled a sequence of numbers and letters and wrote a single word in the margin. The signal was later documented in the Ohio Journal of Science and has been analyzed by researchers ever since. But the unsettling part isn't just that the signal appeared. The transmission occurred at 1,420 megahertz, the hydrogen line frequency, the wavelength produced by the most abundant element in the universe, long proposed by physicists as the most logical channel for any civilization attempting interstellar contact. The signal lasted exactly 72 seconds, the precise maximum duration the Big Ear telescope could observe a fixed point in space as Earth rotated beneath it. Its intensity measured 30 times stronger than the background noise of the surrounding sky. In the decades that followed, astronomers returned to the same region in Sagittarius again and again with increasingly sensitive instruments. The signal never appeared a second time. A signal strong enough to write "wow" in the margin and then disappear forever. Number 9. Oumuamua's anomalous acceleration. In 2017, astronomer Robert Warwick of the University of Hawaii Institute for Astronomy identified an object moving through the solar system on a trajectory that could not have originated here, detected using the Pan-STARRS 1 telescope. Its unusual motion was subsequently analyzed by multiple research teams and documented in Nature in 2018. The unsettling detail isn't that an object passed through our system, it's how it moved when it left. Oumuamua arrived on a hyperbolic trajectory, its path confirming interstellar origin beyond any reasonable doubt. As it began its exit from the solar system, astronomers detected a slight but measurable non-gravitational acceleration, a push that could not be explained by the sun's gravity alone. On Earth, comets sometimes accelerate as outgassing jets of material propel them slightly off course. Telescopes trained on Oumuamua detected no visible comet tail, no detectable gas jets, no dust clouds surrounding the object. Several hypotheses were proposed: hydrogen ice sublimation, radiation pressure from an unusually thin structure, but none achieved consensus. The object entered from deep space, crossed the inner solar system, and was already receding before scientists had fully registered what they were looking at. The first visitor from another star passed through our system, and we barely noticed. Number 8, the Pentagon's UAP report. In 2021, the U.S. Department of Defense released the UAP Preliminary Assessment, a document compiled by the Office of Naval Intelligence drawing on encounters recorded by U.S. Navy radar systems, infrared targeting cameras, and pilot testimonies collected over nearly 2 decades of military operations. But the disturbing aspect isn't that pilots saw something unusual. It's what the sensors recorded. The report analyzed 144 unexplained aerial incidents documented between 2004 and 2021. In a subset of cases, objects demonstrated acceleration profiles and directional changes that exceeded the performance capabilities of any known aircraft, manned or unmanned, in any nation's inventory. Sensor platforms operating independently, radar, infrared, optical, recorded the same objects simultaneously, ruling out equipment malfunction as a general explanation. Several incidents captured objects operating without any visible propulsion system. Many of these encounters occurred in restricted military airspace, reported by trained observers using calibrated instruments. The document did not speculate about origins. It cataloged what the sensors recorded and noted that explanations remained pending. No follow-up assessment has resolved the majority of the cases. After decades of sightings, the official conclusion was simple: most of them remain unexplained. Number 7. Repeating fast radio bursts. In 2020, astronomers working within the Canadian Hydrogen Intensity Mapping Experiment collaboration, CHIME, identified a repeating fast radio burst designated FRB 180916 with findings published in Nature. The detection added a significant and unresolved data point to one of astrophysics' most debated open questions. What makes this discovery unsettling is the precision of the pattern. Fast radio bursts are millisecond flashes of radio energy so intense they briefly outshine entire galaxies, Most appear once and never repeat. FRB 180916 repeats. Its cycle runs to 16.35 days with a regularity that is held across multiple observation windows, active for roughly 4 days, silent for 12, then active again. The bursts originate from a source approximately 500 million light-years away. No confirmed astrophysical mechanism fully accounts for why an object at that distance would produce radio pulses on a precise 16-day schedule. Proposed explanations include orbital geometry, precession, or the rotation of a dense stellar remnant, but none have been verified. The signal continues to arrive on schedule. Across 500 million light-years of space, something flashes, in a rhythm we still don't understand. Number 6, methane spikes on Mars. In 2019, NASA's Curiosity rover used its tunable laser spectrometer to measure atmospheric chemistry inside a Gale crater and recorded anomalous methane concentrations. The findings were published in Nature Geoscience and immediately drew attention from planetary scientists studying the possibility of Martian biology. But the real mystery isn't simply the methane, it's the pattern of its appearance and disappearance. On Earth, approximately 90% of atmospheric methane originates from biological processes: microbial activity, decomposition, metabolic function. Curiosity recorded methane spikes rising to 10 times the background concentration, appearing in brief localized bursts rather than as a stable atmospheric component. More puzzling than the spikes themselves was their duration. The gas dissipated far faster than Martian atmospheric chemistry predicts it should. Current models of ultraviolet photolysis and oxidation on Mars cannot account for the speed of removal. Something is releasing methane into the Martian atmosphere in concentrated pulses, and something is removing it at a rate that does not match known abiotic processes. Both the source and the sink remain unidentified. On Mars, methane rises from the ground and then vanishes. Number 5, the BLC-1 signal. In 2019, researchers from the Breakthrough Listen initiative detected a candidate radio signal designated BLC-1 using the Parkes radio telescope in Muryang, Australia. The signal was subsequently analyzed by the UC Berkeley SETI Research Center over the course of several months before results were made public. But the troubling detail wasn't just the signal itself, it was where it appeared to come from. The transmission appeared to originate from the direction of Proxima Centauri, the nearest star to our own solar system, located 4.2 light-years away. It was a narrowband signal, concentrated at a single frequency in the way natural astrophysical phenomena generally are not, and in the way artificially generated transmissions typically are. The frequency drift observed in the signal initially matched the pattern scientists would expect from a source moving through space, rather than a fixed terrestrial transmitter. The Breakthrough Listen team conducted months of careful analysis before concluding the signal most likely represented a form of radio frequency interference of human origin. The conclusion was not unanimous, and the analysis was not simple. For a brief moment, the closest star in the sky appeared to be calling. Number 4, the hidden population of interstellar visitors. In 2019, astronomer Matthew Knight of the University of Maryland and collaborators used data from Pan-STARRS survey observations to model the expected frequency of interstellar objects passing through planetary systems, publishing their results in astrophysical journal letters. The unsettling implication isn't that we detected one interstellar object, it's what that detection implies about everything we missed. The models Knight's team developed suggested that interstellar objects pass through the solar system with considerable regularity across astronomical timescales. The vast majority would be undetectable with current instrumentation, too small to reflect enough light. So too dark against the background of space present for too brief a window to be caught by survey telescopes operating on human schedules. Oumuamua was detected only because it passed relatively close to the sun and happened to fall within the observational window of Pan-STARRS at a moment when the survey was running. The detection was, in the language of the paper, a matter of probability working in our favor for once. The models do not suggest Oumuamua was unusual, they suggest it was simply visible. The solar system may have been visited countless times. We simply weren't watching. Number 3, the long-delay radio echoes. In 1927, Norwegian engineer Jürgen Holst was conducting radio transmission experiments when he began receiving echoes of his own signals, returning at intervals far longer than standard atmospheric reflection could explain. His observations were later analyzed by physicist Carl Sturmer and mathematician Balthasar van der Pol, and the phenomenon entered the scientific literature on radio propagation as an unresolved anomaly. But the unsettling detail was the delay itself, and the fact that it never fully went away. Standard radio echoes produced by ionospheric reflection return within fractions of a second. HAL's recorded echoes arriving 3 seconds after transmission. In subsequent decades, similar phenomena were reported by other operators, with delays ranging up to several tens of seconds, intervals that no known atmospheric or ionospheric mechanism adequately explains. The phenomenon was documented intermittently through the mid-20th century. Proposed explanations have included plasma effects in Earth's magnetosphere, ducting between ionospheric layers, and, while in a small number of published discussions, the possibility of reflection from an artificial object in a high Earth orbit. No single explanation accounts for every documented case. The phenomenon has not been resolved. Sometimes the signals we send into space come back long after they should have faded. Number 2, the 1991 VG object. In 1991, astronomer James V. Scotty discovered a small near-Earth object designated 1991 VG using the Space Watch telescope at the Stewart Observatory, University of Arizona. The object's behavior during its close approach to Earth prompted discussion in Nature and among planetary scientists studying near-Earth object populations. But what made this object unusual wasn't just its orbit, it was the combination of characteristics that had no straightforward natural explanation. 1991 VG followed an orbit around the Sun that closely resembled Earth's own, an unusual configuration for a natural asteroid originating from the main belt or the outer solar system. Its trajectory brought it to within 450,000 kilometers of Earth, closer than the Moon's average distance. Photometric observations during the approach revealed rapid, irregular brightness. Variations suggesting a tumbling motion, inconsistent with the rotation patterns typical of natural small bodies. Astronomer Duncan Steele of the Anglo-Australian Observatory raised the question in print of whether the object might represent artificial debris from an early space mission. Subsequent analysis favored a natural origin but could not fully account for all observed characteristics. An object with no clear origin passed close enough to study, and then left before anyone could decide what it was. Number 1. The Interstellar meteor over Earth. In 2014, sensors from the U.S. Department of Defense satellite network recorded a meteor entering Earth's atmosphere over the Pacific Ocean near Papua New Guinea. The event was logged and largely set aside until 2022, when Harvard astrophysicist Avi Loeb and collaborator Amir Siraj confirmed its interstellar origin in a paper published in Astrophysical Journal Letters, so using the government sensor data to reconstruct the object's trajectory. But the unsettling implication is what this object represents, not as an isolated event, but as evidence of something that had already happened. The meteor, designated IM-1, traveled at over 60 kilometers per second, a velocity exceeding that of objects gravitationally bound to the Sun, confirming it had arrived from interstellar space. Its material strength, based on the altitude at which it fragmented, exceeded that of the toughest known meteorite classes in existing catalogs. Fragments almost certainly fell into the Pacific Ocean. In 2023, Loeb led an expedition to the seafloor recovery site and retrieved spherules, tiny metallic particles, whose composition is still being analyzed. The object entered Earth's atmosphere undetected, de-disintegrated over open ocean, and was identified as interstellar only years later by a physicist reviewing archived defense data. The WOW signal arrived once and left no physical trace. This one left fragments on the ocean floor. Long before we knew it existed, something from another star fell into Earth's atmosphere. If you want to see more videos like this, click the video on screen now and make sure to subscribe.